So that magnetic data that we just talked about was what helped us understand that Alfred Wegener was actually on the right track, right? That our continents actually move. And that was our first bit of real hard evidence, right, that showed us that our continents are in motion. Now what's interesting is that the magnetic information that we got came from the continents, but we were also able to find magnetic information from the ocean floor. And we discovered a lot about the ocean floor during World War II, mostly kind of as a side consequence. So in World War II, right, we were looking for submarines. So they started using echo sounding and mapping out the sea floor. And in doing so, we were actually able to pick up information about the geology, and not just look for submarines and warheads and all that good stuff that we didn't know before. So this side consequence of a pretty terrible war was actually a whole lot of geologic advancement. So mapping the ocean floor led us to see that there were several major features on the ocean floor. The first are mid-ocean ridges. The mid-ocean ridge, as you can see in this picture down here, is located in the center. Okay. The ridge itself has mountains on either side, and then in the middle has a very big low spot. Right? So that's our mid-ocean ridge. Our deep sea trenches, which you can see over here and over here, can be pretty deep. The deepest one is a little over 6 miles, right? So that's pretty deep. And they tend to be found mostly around the perimeter or on the edges of the ocean, very specifically all along the Pacific Ocean. And what's also interesting is also with these trenches, what we find coupled are volcanoes, right? So wherever we have a trench, we see volcanoes on the other side. We also found lots of ocean islands, okay, that are around. And some of those islands are either seamounts or guyouts. Seamounts, as you can see kind of in this picture here, and these are seamounts also, are these conical-topped islands. They were once volcano but are extinct, right? So they are definitely no longer erupting, but they are conical-topped. Now, over time, seamounts turn into guyouts. Guyouts, you can see here, are flat-topped. So as that wave action constantly hits the top of the seamount, it's going to wear off the top, right, and make it nice and flat. We also noticed a couple of other things, right? We see these things called fracture zones, which you can see up in this picture. So what you might notice is here is outlined in red is my mid-ocean ridge. But the mid-ocean ridge is not a straight line. You can see that it's offset, right? And those offsets, right here, are what we call fracture zones. And the last major thing that we can see, right, from this mapping right after World War II is the abyssal plain, right? The abyssal plain is the flat part of the ocean, really kind of just looks like Kansas. For the longest time, up until we discovered this information, people basically thought that the whole ocean looked like the abyssal plain, that it was just flat and featureless. So as you can imagine, this was really a huge surprise to find this information. So today, right, because we have all sorts of fantastic satellites and much better technology, we can see where our mid-ocean ridges are. Right, as you can see, they run through the middle of the ocean. We can see where our trenches are, okay, it's mapped out here in these purple lines, right, like over here, for example, okay, and over here. And we can see those transform faults, right, so you can see all along the mid-ocean ridge how everything is separated. So let's look in the next section about the ocean floor anatomy. So let's kind of get a little bit under our belts.